Yes, we can have a party if we do something great.
Yes.
Okay. All right, so now we're back to review. So have we taken care of all of the questions from the paper, all the papers that I've turned back? You all have, what, a couple of quizzes, 7 homeworks? Well, if you turn them all in, you've got 7 back. You at least have a pile of homeworks, right? We're all set on all that? No questions? Okay, let's look at the review sheet then. And just based on a couple of questions that were asked earlier, let's make sure we can do a couple of these. I am going to just pick and choose. All of this is potential test stuff, so we need to be able to do all of it. But I'm going to start with number 4B, because we had a circle question earlier, and I want to make sure we've got that solidified. So this is a different question, but it involves a circle and a couple of other concepts. So the scenario is this: we have a diameter, and these are the endpoints of the diameter. And we're going to write the equation of the circle. Okay, this is question 4B on the review sheet. The review sheet really doesn't have adequate room to write on, so maybe you're doing this on a separate sheet of paper or something. Or maybe you're squeezing it in there, I don't know. Now, you can kind of still see it from earlier. The equation of a circle looks like this, right? And in here we have an x minus something, or y minus something, and then we have a number here. Agreed? That's what the equation of a circle looks like. So make sure you know the goal. The goal is that. Now, what goes here? The coordinates of the center. So now we have to come back over here to our situation. This is a diameter, so the center would be right here. How are we going to find it? We're going to average the x's and average the y's, right? So 2 plus 4, well, is 6, divided by 2 is 3. And negative 2 plus 6 is 4, divided by 2 is 2. So our center of our circle is at 3, 2. So x minus 3, y minus 2. Now, what goes there?
You're gonna have to find
The radius squared. So this is going to be the radius squared. So I need to come over here and either find this distance or this distance. It'll be the same, right? So one of those, find one of them, and that's going to be the radius of the circle. So how do we find the distance between 2 points? Distance formula. And the distance formula is x minus x, y minus y. Square them, add them up, and square root them. This is kind of this base knowledge we have to have. We have to know how to do the distance formula. So that's 1 plus 16. Now be careful. The number that goes in here is the radius squared. So what am I going to put in here? 17. That's the equation of your circle. All right, is that okay with everybody?
Yep.
All right, I'm going to grab that one. Let's look at number 10. And then I want you to pick some, okay, for me, please? But I'll do number 10. Different round trip airfares from Boston are all listed, okay. Using the data for Buffalo and Houston. So 400, 118, and 1600, 298. So I'm setting my ordered pairs up where x is the distance and y is the cost. In this problem, Yeah, that's the best way to set it up. And that's kind of the way they're already arranged. All right, it says find a linear function. What does that mean? Write the equation of the line? Just a fancy way of saying write a line?
Yeah, like.
So how do we write a line? Start with the slope? Dan, you okay?
Yeah.
Alright, so I'm starting with the slope, so 298 minus 118 over 1600 minus 400. Now I can use a calculator to help me with that. It's not too bad of arithmetic, but it is after lunch. We're a little drowsy. I got 0.15. Did you? Then I'll pick a point, doesn't matter which one. I guess I'll just take the top one, the smaller. So y minus 118 equals 0.15, x minus 400. I'm gonna go ahead and put it into slope-intercept form. I got 0.15x plus 58. I don't know if that's right.
Yeah. Or would it be, yeah, or, yeah. Yes.
Is that a yes or a no?
Yes.
Alright, so I'm not gonna be confused when it says something about linear function. That's just, I'm writing the equation of the line. So I got my slope, did my point slope. I could have stopped here, but I know there's more coming, so I went ahead and put it into slope-intercept form because I know there's a second part to the question, which is, if it costs $172 to fly to Indianapolis, how far is it from Boston to Indy?
Is Indy on there?
No, that's right, we're finding it. So they're telling us, they're giving us, and we're finding the information for Indianapolis. So where do I put the 172? Remember how you set up your ordered pairs? That's $172, so where does that go?
The Y.
That goes in for Y, so I'm gonna put 172 right here. And I'm gonna solve that. And that will give me the information. So 172 minus 58. And I'll divide. I got $760.
You mean, or distance?
Yep. Oh, miles, yeah, sorry, not dollars. 760 miles, that's the distance. Everybody okay with that? I don't want you to freak out when it's a word problem. The word problems just use your normal skills. Okay, as you were looking through this earlier, when I was passing back papers, did anybody find a question that you weren't sure about? 3B. 3B, oh my. Yes, Amanda. Now, it's an easy problem, but it sure does look scary. So, what is this? What shape is this? Isn't it a circle? Where's its center? The origin? So basically that guy looks like this. He's centered at the origin and he has a radius of root 5, whatever the square root of 5 is, 2.2 or whatever, right? That's that. Now, on this circle is the point 1, 2. So this is the point 1, 2. And you are supposed to write the equation of the line tangent, oh my gosh, you remember anything from geometry?
Isn't it like opposite over adjacent or something like that?
Okay, right triangle trigonometry, tangents opposite over adjacent. You're exactly right, so the TOA. But we are talking now about a tangent line. So a tangent line is a line that hits the curve once. So that's a picture of a tangent line. I don't really have a triangle, so I can't really do opposite over adjacent, but yes, that's another interpretation of what a tangent is. What do I need to write the equation of a line? I need a slope, and I need a point, right? Now I have the point. I somehow need the slope of that line. All right, Ellie?
Wouldn't the radius of the circle be perpendicular?
Exactly. That's what I was hoping you remembered from geometry. That a radius and a tangent are perpendicular at the point of tangency. So, I can't find the slope of the blue line, but can I find the slope of the black line? You only have 2 points?
Yeah.
So what's the slope of the black line? 2 minus 0 over 1 minus 0. So that's 2. What does that make the slope of the blue line then if it is perpendicular to the black one? -1/2. So now you can write your equation because you have your slope and you have your point. Y minus 2 equals -1/2 x minus 1. And then it doesn't really say how to write that answer, so that's good. Or you can get y by itself if you want to. All right? Now, I promise that on test day, I'm not gonna sneak in anything we haven't talked about. Now, we've talked about this now, right? We've talked about this, so this would be fair game. But I'm not gonna sneak in some other geometry thing that you probably should remember, but if we haven't talked about it, I might put it on there. Okay? All right, what else? That's a great question, Amanda, thank you. What else? Should we do a graphing one on our calculator? Let's do 9. I know the equation looks easier, but 9 is an inequality. And we're gonna review tomorrow too. So after you've had a chance to practice some of these on your own tonight, hopefully you'll have a chance to practice a few. We can do more tomorrow if you want. But this one is an inequality. And that doesn't really change much of anything until we get to till we're ready to write our answer. All right, so what are your suggestions here? What do you think we ought to do?
Let's subtract 12 too.
Yeah, let's get a 0. Now, we are solving this on our calculator. We could do this by hand, 100%, but we're gonna solve it on our calculator. So I know some of you are looking at that saying, that factors. Yes, it does, but that doesn't matter if I'm graphing it on my calculator. All right, so here's what I'm gonna do now. I'm gonna go to my standard window. So how do I get a standard window? Zoom 6. Then I'm gonna go to y equals, because that's the only way I can graph things, is to go to y equals, clear out anything that's in there, x squared minus 4x minus 12. And then I'm gonna hit graph. And so notice how there's a box on there. This is the way your test is gonna be. You have to show me what you see. You have to tell me what your window is. So I've got a standard window, so my x's are gonna be -10 to 10, and my y's are -10 to 10. Now, they can be different things, so if you wanna change those numbers, you absolutely can. That's what I have, and I have a perfectly fine picture. It comes down here and looks like Well, it actually goes off the screen down here. Is that what yours looks like?
Yeah.
And that's fine, because I am interested in this point and this point. If you are uncomfortable because you can't see the bottom of your parabola, then you can change your minimum here to go lower, and you'll see the bottom of your parabola. But that really isn't the question. I need these 2 points. Okay, so how do we find those points? Second calc 0, option 2. Remember, if you can't see your cursor, when you press second calc, the cursor should come up. If you can't see it, the calculator tells you where it is. Just keep clicking left or right, and it'll come into play. I got -2 over here. Again, I know this problem factors, but we are pretending it doesn't. We're solving it graphically, and I got 6 for that one. Now, for problem number 8, the answers would be, if the equation, if it looked like number 8, if that was an equals, the answers would be -2 and 6. But that isn't the question. The question is, where is this equation either equal to 0, so that's right here, this is where it equals 0, or is greater than 0. Greater than 0 means positive. So that would be this part of the curve and this part of the curve. Would you agree with that? Whenever your problem is an inequality, you're going to have intervals as your answer. Don't ever just say x equals 5 or something. It's intervals if it's an inequality. So what are the intervals? Remember, we're looking at x values. X values. This is an x equation. Jake?
Negative infinity with the regular parentheses, -2 with the box parentheses, and then union, box 6, the positive infinity regular parentheses.
I don't really care if you call that a box, it's a bracket, but that's why you call it a box. I mean, we know what you mean. Right? Remember, we're looking at the x's. So all the x's to the left of -2. If you were doing this on a number line, it would be like shading out. Remember that on the number line? That's exactly what's happening here. Only we're shading out on the parabola. Katie?
So is it the same as the number one if it's, if it were to be less than, would it be the one where it's like a number to a number?
Yep, that's exactly what it would be. So if you turn this around and made it less than or equal to, it would be this part of the picture, so it would be -2 to 6. Brayden?
On like the quiz or test, like how you drew it, like where it just comes off negative, is that okay to draw it on like that on here too?
Everything I drew up here is absolutely fine. If you drew this on your paper, that would be fine. Because remember, when we're looking for zeros, this is all I really care about. The rest of the picture is kind of irrelevant. But some people really like to see the bottom, so you can change that number. There's nothing sacred about these numbers. They can be different. I just always start with that. All right, let's do one more. One that I have time to do what?
Do the velocity one.
We can start it. I don't know if we can get all the parts done, but we can finish it tomorrow. So, I am not gonna ask you to memorize the velocity formula. This is called the projectile motion. You will have this just like you do on the review sheet here. And what you need to do before you start, this has problems A, B, C, D. We need to write the equation that is appropriate for this particular problem. So, a ball is thrown straight upward from a height of 6 feet. Where does the 6 go? Right here. This is the starting height. We call call it the initial height, it's the starting height, so it has to be plus 6. With an initial velocity of 30 feet per second. So that's step 1. I'm gonna give you this general formula, but you have to customize it to your problem. Now, I think we talked about this. This is function notation like f of x. Did we talk about that? And f of x is the same as y. If you had an equation that looked like this, you would say y equals 2x plus 3. So I can say y equals or h equals, because this is height. So I'll call it h. You can call it y, you can call it s of t, but this represents the height of the object. So this is the equation I'm going to use for this particular problem. So question A. Oh, okay, that's it. That's question A, right? That's question A. Write the equation. There it is. Find the height of the ball at 1 second. So here's your equation. There's 2 variables, height and time. They said, find the height of the ball at t equals 1 second. Guess what I'm going to do with that 1? Plug it in for t. So h equals negative 16. And I don't think anybody in here would mess this up, but remember, you're not squaring the 16. You're squaring the 1. So this is negative 16 plus 30 plus 6. I'm getting 20 feet. Does that sound about right?
Yeah.
20 feet. All right, I'm going to stop there because we're almost out of time. So I'll make a note to myself, and if I forget, someone remind me that we're going to finish this problem tomorrow. Okay? But the other parts that we use, we'll use that same equation. That's the equation that we'll use.